Hello students, this is Vijaya Janardhan Ushir working as assistant professor in Maratha Vidyaprasarak Samaj Nasik. This is the third lecture of our surface chemistry chapter. In the last lecture, we have studied what is the difference between physical adsorption and chemical adsorption. In that we have in detail studied that what do we mean by physical adsorption, which was also called as a van der Waals adsorption, and next one type was the chemical adsorption, or it is also called as a chemisorption. So in the last lecture we have already studied the difference between the physisorption and chemisorption, but in this lecture we will revise this again because this is important in examination point of view. So what is physisorption? So we have studied that physisorption means the adsorption by van der Waals forces. Therefore, here the adsorbate molecules are held on the surface by weak van der Waals forces. And what happens in the chemisorption? The adsorbate molecules are held on the surface by the chemical bonds. So name itself indicates that here the molecules are held on the surface by chemisorption means chemical bonds, and physisorption means weak physical bond. And which are these physical bonds? That is the van der Waals forces. And physisorption is reversible in nature and chemisorption is irreversible in nature because there is a formation of chemical bond and the breaking of chemical bond is very difficult. Therefore, the process is irreversible. But van der Waals forces in the physisorption are weak. Therefore, the process of physisorption is reversible. And the physisorption is not very specific in nature, and the chemisorption is highly specific in nature. It forms a multimolecular layer. Means in the physisorption it forms multimolecular layer, but in the chemisorption it forms only the monomolecular layer. And physisorption usually takes place at low temperature and decreases with increase in temperature. Means the physisorption occurs at low temperature and it decreases with increase in temperature. And it takes place even relatively at high temperature. Means the chemisorption takes place at high temperature. And the enthalpy of adsorption for the physisorption is very low, that is up to the order of 20 to 40 kilojoules per mole. But in case of chemisorption, the enthalpy of adsorption is very high, that is about 40 to 400 kilojoules per mole. And in the physisorption, normally it does not involve any energy of activation. But in the chemisorption, it requires the activation energy because here are the formation of chemical bond. Therefore, the reactant molecule must have to pass through the barrier. We have already studied in the first chapter that what is the activation energy, that the minimum amount of energy that the reactant molecule must acquire before they could react. And in the chemisorption, the chemical bond formation is there, therefore it requires the activation energy. But in the physisorption, it involves only the weak van der Waals forces, therefore it does not involve any energy of activation. So this is the difference between physisorption and chemisorption. So we will move towards our next point of the chapter, that is the adsorption isotherms. So what is this adsorption isotherm? We know the process of adsorption, and what is the meaning of adsorption isotherms? So the relation at constant temperature, because the isotherm name itself indicates that iso means constant and therm means iso means same or constant and therm means temperature, means the relation at constant temperature between what is the adsorption? Between the amount of substance adsorbed by the adsorbent and the pressure or concentration at equilibrium is called as a adsorption isotherm. Means isotherm means the process at constant temperature. And what is adsorption? The process between the amount of substance adsorbed by the adsorbent and pressure or concentration at equilibrium. It is called as a adsorption isotherm. So there are mainly two types of adsorption isotherm. First is a Freundlich adsorption isotherm and second one is a Langmuir adsorption isotherm. So in this lecture we will study the Freundlich adsorption isotherm in detail. So what is the Freundlich adsorption isotherm? It is an empirical equation used for the variation of extent of adsorption with the pressure at constant temperature over a limited range of pressure. Means the empirical equation which gives the variation of extent of adsorption, means up to which extent the adsorption is taking place with pressure, but what condition is there? Isotherm is there, therefore the most important condition is the constant temperature, and it occurs over a limited range of pressure. Means the Freundlich adsorption isotherm is only occurs for the limited range of pressure, and this phenomenon was put forth by the Freundlich in 1907, and therefore it was called as a Freundlich adsorption isotherm, and mathematically it is expressed as x upon m is equal to k p raised to 1 upon m. So what is the x? So x is the mass of gas adsorbed, means the which gas is adsorbed on the surface of adsorbent, that quantity is called as x, that is a mass of gas adsorbed. What is m? M is a mass of adsorbent. What is x upon m? Therefore x upon m is the ratio of mass of gas adsorbed per unit mass of adsorbent. Next is the P. What is the P? P is the equilibrium pressure, and this K and N are the constants. This K and N are the empirical constant and which are dependent on the nature of adsorbent and adsorbate and also the temperature. So this is important that K and N are empirical constants dependent on the nature of adsorbent, adsorbate and temperature, and N is always greater than 1. Therefore, the amount of gas adsorbed always increases less rapidly than the pressure. Means N is always greater than the 1. So what happens? The amount of gas adsorbed increases less rapidly than the pressure. As rapidly pressure increases, the amount of gas adsorbed is relatively less rapidly increases, and the Freundlich adsorption isotherm has no theoretical importance because it is applied to only limited range of pressure, and it holds only up to the medium pressure of the gases. Means it is only limited to the some pressures, therefore it is not of theoretical importance. And in case of adsorption of solute from the solution, the similar equation is applicable, and which is written as, means in the solution form we have written this Freundlich adsorption isotherm as x upon m is equal to k p raised to 1 upon n is replaced by c raised to 1 upon n, because we are studying the reaction of solute from the solution. Therefore, in the solution phase we consider the concentration, but in gaseous phase we consider the equilibrium pressure. Therefore, the P is replaced by C. Therefore, the equation is x upon m is equal to k c raised to 1 upon n. We know that what are these k and n? K and n are the empirical constant. What is x? X is the mass of solute absorbed. In the earlier, what was x? X was the mass of gas adsorbed, but here the process is solute from the solution. Therefore, x is the mass of solute adsorbed, m is the mass of adsorbent, x upon m is the mass of solute adsorbed per unit mass of adsorbent. And what is this C? In the earlier, here the term was the P, that is the equilibrium pressure, but here is the C, that is equilibrium concentration of adsorbed substance. Means adsorbed substance which is also called as an adsorbate in the solution. So C is the equilibrium concentration of adsorbed substance in the solution, which is also called as an adsorbate. Means it is the equilibrium concentration of adsorbate in the solution. So how the Freundlich adsorption isotherm is indicated? By the graph. If we plot x upon m versus P. So if we got the graph like this. So here x upon m, here in this range x upon m is proportional to P at low pressure. Means here the pressure increases. At low pressure, what is happens? The X upon M, that is the mass of solute adsorbed per unit mass of adsorbent, is proportional to P at low pressure. What happens as pressure increases? Means if we move here, so here also the pressure increases. Therefore, X upon M is proportional to P raised to 1 upon M. And this is the condition at intermediate pressure. What happens here? We move again forward, therefore X upon M is a constant at high pressure. So this is the high pressure conditions. So as X upon M increases, pressure also increases, but X upon M is a constant. We observe here the straight line, like a straight line curve is obtained. Therefore, we can say that X upon M is a constant at high pressure. So this is the curve for Freundlich adsorption isotherm, and the curve approximately has a parabolic shape. So this curve has approximately parabolic shape, and if X upon M is plotted against the P, so smooth curve is obtained, and the first part of curve is a linear. So this first part of a curve is a linear because at very low pressure, what happens? The X upon M is proportional to P. But as we move forward, what happens? At intermediate pressure, X upon M is proportional to P raised to 1 upon N. And at last point, that is at high pressure, the X upon M limiting value of pressure is reached. That is X upon M is a constant at high pressure. Means at the pressure increases, the amount of gas adsorbed per unit the mass of adsorbent is a constant. That is X upon M is a constant at high pressure. So this is the Freundlich adsorption isotherm. So we know the equation X upon M is equal to Kp raised to 1 upon N. That is X was the amount of gas adsorbed and M was the mass of adsorbent. What is the K and N? These K and N are the constants, and this P is the equilibrium pressure. So if we take the log on the both sides of above equation, so if we take the log, so what we got? The log of X upon M. So the log of this X upon M, and this is log of K, this K into P raised to 1 upon M. According to logarithmic rules, we can write as this K into P can be written as log of K plus log of P. But here is the P raised to 1 upon N. Therefore, in the logarithmic form, we can write as log of X upon M is equal to 1 upon N log P plus log K. So, this equation is of the form y is equal to mx plus c. So, this is if we plot log of X upon M on the y-axis and log P on the x-axis. So, what we got? This 1 upon M as a slope of a straight line, because this is y is equal to mx plus c is the equation of straight line. Therefore, if we plot log of X upon M versus log P, therefore the slope of the graph is straight line. The slope of straight line graph is 1 upon N, and what is this c? C is the y-intercept, and y-intercept is equal to log K. So if we plot log of X upon M versus log P, so what we got? This is a straight line, but it is not passing through the origin because it has the value of some intercept which is equal to log K. So what is the slope of this graph? Slope is equal to 1 upon N. What is this is called as a y-intercept, and y-intercept value is the log K. Therefore, this equation is of the form of y is equal to mx plus c, which is the equation of straight line. Therefore, if log of X upon M values are plotted against the log P, a straight line is obtained. Thus, we can say that y-intercept is equal to log K and slope is equal to 1 upon N. Therefore, from the graph of Freundlich adsorption isotherm, we can calculate the value of K and N. So these are constants, that is K and N. These values can be calculated by plotting the graph of Freundlich adsorption isotherm. So this was all about the Freundlich adsorption isotherm. So The most important condition is that the Freundlich adsorption isotherm is applicable to only limited range of pressure. So it has no theoretical importance. So the equation is x upon m is equal to Kp raised to 1 upon n, and in case of solute from the solution condition, the equation is x upon m is equal to Kc raised to 1 upon m, 1 upon n, and this is the important from the examination point of view. That is a Freundlich adsorption isotherm. Next one is the Langur adsorption isotherm. So that Langur adsorption isotherm, what is the Langur adsorption isotherm, and what are the applications of Langur adsorption isotherm? So that all we will study in the next lecture in detail. So thank you.